Alright, so as we say, organic compounds can be broadly broken down into two. Follow me. Either you are cyclic or you are acyclic. Okay, I put acyclic here in the other one. And cyclic. Follow me. And I was explaining something. I said, if you have an organic compound with a 3-carbon structure like this, whereby obviously every other space is filled up with hydrogen. Follow me, please. Class, as it stands now, this structure is acyclic because it lacks a cycle. It lacks a what? So it's acyclic. Another name for cyclic is ring structure. Any structure that is in ring form is what? Cyclic. Follow me. But acyclic means aliphatic. Ali what? So if you want to call you acyclic, I can call you aliphatic. Let's put it beside it. Aliphatic. Please follow me. So this guy now is acyclic or aliphatic. But class, this same guy that is aliphatic can be what? Transformed to a ring. Class, usually in the ring, even the carbon is not shown. So if I want to remove all these carbons, what I have is a triangle. Once an organic compound moves from aliphatic to cyclic, or let's say from acyclic to cyclic, let's use their first names. From acyclic to cyclic, they will lose 2 hydrogen. They will lose what? Look at this carbon, 3 carbons, and when it becomes cyclic, I will show you how it loses 2 hydrogens. Remember that this hydrogen, follow me. Hydrogen. How many hydrogens are here now? 8, right? C3H. Count 1, 2, 3, 4, 5, 6, 7. But class, watch this carbon that these same 3 carbons are now fused together to form a ring or a cycle. Do not forget that each of these things still represents bonds. And every carbon can only have 4. So if this is 1, 2, how many more bonds can this guy take? 3. If this is 1, 2, how many more bonds can this guy take? 1, 2. So you put hydrogen here, hydrogen here, hydrogen here, hydrogen. What then happens is this, that we don't have how many hydrogens now? 6. We have what? So someone that had 8 hydrogens when it was in its aliphatic form is now having what? 6 in cyclic form. Are we following class? So 2 hydrogen atoms are lost during transformation of compounds from acyclic to cyclics. Now follow me. Under this acyclic class, which means aliphatic, we can still have what we call straight chain So straight chain are cyclic and what? Branched. Class, if an organic compound just has a continuation of carbon without any branch, any of the carbon branching, it is a what? Straight chain. This is a what? And you can see another organic compound whereby some carbons are straight, while some are now branching to other sides. This is a branched chain. So you can have straight chain and what? Branch chain. And this guy's classification ends here like this. Coming to this other side, this cyclic continues. These cyclic organic compounds can be divided into two broad types. It's either you are aromatic or non. There are two types of cyclic class. Is either you are aromatic or you are non-what? Aromatic. Class, under the aromatic, two of them have cycles. That means it is short. Since two of them are under cycle, they both have cycles, right? They both have rings. The only difference is that this guy's ring, aromatic cyclic, their rings contain 6 carbons precisely. So if you have less than 6 carbons, you cannot be an aromatic. So as a general rule, please take note normally. The number of sides for a cyclic compound represents number of carbons. The number of what? Sides represent number of what? So if this guy has 6 sides, it means he has 6 carbons. So what that means is that aromatic cyclic hydrocarbons have 6 carbons, contain 6. If you have less than 6 carbons, you cannot be aromatic. If you have more than 6, you cannot be aromatic. You must have exactly 6. So aromatic cyclic, as cyclic, you can see it's cyclic. It's not straight open like it's cyclic. But it's specific cyclic. It has 6 sides. It must have 6 carbons. Each side represents number of carbon 1, 2, 3, 4, 5. And not just that, they have what we call alternating single and double bond pairings. Class, after every double bond there's a single bond that comes in. After every double bond there's a single bond that comes. So you can see double, single, double, double. So for every double bond there's a single bond. For every double bond there's a single. You must note that about aromatic. Meaning that remember that every carbon must always have 4 bonds. So if you actually look at the structure, you will see that aromatic cyclic has 6 carbons and 6 hydrogens. Because each side represents carbon, right? Now if you count, these are bonds. For this carbon, it has 3 bonds with him already. 1, 2, 3. You can only take 1 more bond to make it 4. Every carbon must have 4. 1, 2, 3. How many can you want to take? 1 more bond. 1, 2, 3. 1 more bond. 1, 2, 3. 1 more. 1, 2, 3. 1 more bond. 1, 2, 3. So every carbon can only take 1 more bond. Who speeds up the bond? Hydro. I told us yesterday, after carbon, the most populous element in organic compound is hydro, followed by oxygen. Followed by what? After carbon. Carbon is the most popular element in organic compounds. After carbon, immediately is hydrogen. After hydrogen, the next person is what? Oxygen. So what this means is that the molecular formula of aromatic hydrocarbon is C6H, 6 carbon, 6 hydrogen. 6 carbon, 6. Are you following? Class, you know the funny thing about aromatic, this is where his own story ends, based on structure. Based on what? Because class, when we get to benzenes, they are culturally called benzenes or arenes. Aromatic hydrocarbons are called what? Or arenes. Key point to exam. Your exam is subjective, so key point. Benzenes or arenes. Aromatic, benzenes or arenes. This is what you need to know based on structure. But class, when we come to benzenes as a topic later, because class, you know the funny thing, I just did alkane-alkynes, right? But I'm not done with alkane-alkynes. I'll still come back to alkane-alkynes, give you their reactions. I just give you the foundational intro first. We'll still come back to alkanes, reactions of alkanes, nomenclature of alkanes, physical properties of alkanes, all those things, how they are prepared, everything about alkanes, everything about alkanes, everything about alkynes. So same thing with benzenes. We also look at benzenes and their reactions and all that. Because this benzene, any of the hydrogen can be replaced easily. We don't come to reactions. Any of the hydrogen can be replaced with another substituent. Class, for now, if you want to name an aromatic compound, just call it benzene. Just call it what? If there's no other element attached to the aromatic, it's just benzene. It's called what? But once someone now comes in and replaces the hydrogen, if any of the hydrogen is replaced, the name will change from just benzene to chloro. So when there was nobody attached, it was just benzene, right? But a chlorine now came in, it becomes chloro. If 2 chlorine comes in, it becomes 1, 2 dichloro. 3 chlorine come in, 1, 2, 3 trichloro. We will come to top nomenclature. So that one is coming. That one is what? Coming step by step. Now, quickly, let's move forwards. For this aromatic, we now have what we call homoaromatic, heteroaromatic. But don't bother yourself, it's not really that difficult. Homo means that an organic compound containing carbon and hydrogen only is homo. Is what? But when an organic compound contains carbon, hydrogen, and any other extra substance, any other element, it's heteros. So homo means that you contain only carbon and hydrogen. Only. Throughout the chemical structure, you are only what? Carbon and hydro. So homoaromatic is just benzene without anybody attached to it. But heteroaromatic is that benzene when I now introduce chlorine. When I introduce what? It becomes an heteroaromatic. Because it's not just carbon and hydrogen that is in the structure, there's another element that is also present. Are we together, class? For the non-aromatic class, we also have homo and hetero. Homo and what? Class. Generally, cyclic hydrocarbons, their first member is 3 carbons. Class. We have not yet found a way of how to turn 2 carbons into a cycle. Is it possible? Does anybody have an idea? So you can see that you cannot have a cyclic organic compound with just 2 carbons. But there's no way to. 2 carbons are linear to each other. How do we make them a shape? Is there any shape that just has 2 sides? See? So over the years they've been studying this organic chemistry. Nobody has been able to find out how to turn just 2 carbons to a ring. So the lowest member of the cyclic family as a whole is 3 carbons. What? And from there we'll keep taking it like that. So class, in cyclic, for this aspect, for non-aromatic, we name them based on the number of sides, and their naming must start with cyclo. For non-aromatic cyclic, your naming starts with what? For aromatic cyclic, does your naming not start with cyclo? No. How do we name aromatic cyclic benzene? That means if you are homo, we'll just call you benzene. It means you don't have any other person, you are just benzene, right? But if you are hetero, whoever is attached to you will call that person first, then you end it with benzene. If it's chlorine that's attached to you, chloro. If it is bromine, bromo. Iodine, iodo. If it's methyl, methyl. Benzene. If it is whatever. Even if it's your name, Jennifer, benzene. I always get a class. Now follow me. So benzene is very simple. Benzene is very. Now coming to non-aromatic nouns. For non-aromatic, you must start the naming with cyclo before you do anything. You must start naming with what? Then you count the number of sides. This guy has 3 sides. When you have 3 sides, what do your naming start? It's not pro to cyclopropane. Cyclo what? Propane. But if I have 3 sides and you have 1 double bond here, you now become cyclo what? Propane. Cyclo what? Propane. You get the idea now? So for non-aromatic cyclic, your naming must start with cyclo. Then the number of sides represents the number of carbons. If it was 4 sides, cyclobutene or butane. If 5 sides, cyclopent. 6 sides, cyclo-X. Because class, some students used to confuse benzene with cyclohexane. Class, cyclohexane also has 6 sides like benzene. Remember that benzene must have 6 sides, 6 carbons. But just that in cyclohexane, there's no double bond inside, alternating single and double bonds. If we look at these structures, class, this benzene. How do you recognize benzene? After every double bond is a single, after double single, but class, let me draw that structure here. Look at this. This is not benzene. If you cannot count 3 double bonds and 3 single bonds, it is not. You have to name this normally. Once you are not benzene, your naming must start with cycle. Must start what? Cycle. We're not going to ask ourselves how many sides? 1, 2, 3, 4, 5. Cyclo X. Cyclo what? X. We put an I. Put what? Please note this very early. Anytime you are naming organic compounds, after writing an alphabet, you want to put a number next. Do not just write a number immediately after an alphabet. So I to X. Are we joking here? No. Let an hyphen separate an alphabet from a number. These little details might be a big difference between some of you can name, but you don't know the small little rules that we have. I don't know why am I still having this result. there are some concepts they are looking at for when naming organic compounds. There should be an hyphen between an alphabet and a number. And between a number and a number, like 2, 2, it should be a comma. Don't use hyphen for 2 numbers. You are wrong. It should be a what? 2, comma, 2. Then you want to now mention an alphabet, hyphen or something. Don't write number and just put a cyclo. No. 2, 2, hyphen before you can write an alphabet before after a number. So before a number or after a number, you want to put an alphabet. Always start with an hyphen. Please take. So I want to name this person cyclo, right? Because it's a cyclic hydrocarbons. But this guy, when you say cyclo here, no, I'll just say benzene. So benzenes do not start with cyclo, but this one cyclo X. X square has 6 sides. X square has what? If it has 7 sides, only be cyclo X, right? 8 sides cyclo oct. For 6 cyclo X. Now class, I must number this. There are 2 double bonds here. If there was only 1 double bond, it would have been cyclo X. Cyclo what? I would have been done. Just 1 double bond, cyclo X, I'm done. But there are 2 double bonds, class. So I cannot just say cyclohexane. I must now number the double 1, 2, 3, 4, 5, 6. Class. Why is it important that my number 1 was here? I could have put my number 1 here, class. But in this structure, anywhere you have special bonds, that place should be where you start counting from. So there are 2 possible places I should start counting number 1, either from this or from this. If I started number 1 here, automatically number 2 must be here, because class, when naming organic compound, there's a double bond. Your first carbon 1 and 2 must be between the 2, but your carbon 1 and 2 must be the double bond space. So if I said 1, it's wrong to not say 2 here, and it's not double bond here. So if this 1, this must be, and if this is 1, this must be, then you must keep going like that. So once you started counting clockwise or anti-clockwise, maintain that position. Like going like this anti-clockwise, right? Yeah. So if I said 1, 2, don't have to say 3, say 4. We are not, do you understand? So if you are started going like, continue like that today, if you are going like, but it's wrong to go like when there's a double bond. If this was all single bond, then you can have gone, you can go anywhere. 1, 2, 3, 4, or 1, 2, 3. But if there's a double bond, you are mandated to go in the direction of the double. 1, 2, 3. Please take. Now, like it's now clear that we have 2 double bonds. The first double bond between carbon 1 and 2. On that rule you will learn now. When naming organic compounds, always go for the give what? Credit to the lesser number. Give credit to the lesser. So this double bond between carbon 1 and 2, we're going to give it to carbon 1. So that's going to be 1 here. This one between 3 and 4, we'll give it to carbon. So my naming now becomes cyclo X1, 3. You see, I put a comma between 1 and 3. Between 2 numbers, put a. Now I want to write an alphabet. Now before I put an alphabet, I must introduce under hyphen. Cyclo X1, 3. I will not just say in, die. Cyclo X1, 3, die. Why did I say die in? Because die means that it's telling that there are 2 double. The first double bond was on carbon 1, second one is on carbon 3. You know that actually double bond cannot exist on just 1 carbon. It's always going to be between 2 carbons, but always give it to the lesser. So between 1 and 2, give it to. Between 3 and 4, give it to 3. Thank God there's a video. In case I have too fast, you can always go and watch again, pause it and watch again and again. Now, cyclo X1, 3 dyene. One now makes you an hetero non-aromatic. So this guy is still homo non-aromatic. Homo, why? Because he only has carbon and hydro. Class, if I now introduce, okay, even this structure is like this now. I also now introduce chlorine. I also now introduce what? So this name still exists, but you now be 1 chloro, 1 what? 1 fluoro cyclo X1, 3 dyene. 1 cyclo X1, 3. Because the parent name of this compound must always end it. The parent name is, before chlorine came in, what was the parent name? Cyclo X1, 3 die. When naming organic compounds, the last name must be the parent name. So every branch should come first for the parent name. So 1 chlorocyclo X1, 3 die. Are we together, class?
Yes.
This is structural classification of organic compounds. Structural what? Classification of organic compounds. Now follow this. The next thing in our outline is index, IHD. Index of hydrogen deficiency. Index of hydrogen what? IHD. IHD. How to calculate IHD, index of hydrogen deficiency. Index of what? Of hydrogen deficiency. Index of hydrogen deficiency. Note class that index of hydrogen deficiency is also called mode of unsaturation. Mode of what? Unsaturation. Another name for index of hydrogen deficiency is mode of unsaturation. Another name for index of hydrogen deficiency is what? Mode of unsaturation. Another name for index of hydrogen deficiency is mode of what? Saturation. Now write down. The index of hydrogen deficiency represents the number of double bonds. The index of hydrogen deficiency represents the number of double bonds or triple bonds or rings present in an unsaturated organic compound. Index of hydrogen deficiency represents the number of double bonds or triple bonds or rings present in an unsaturated organic compound. Number of double bonds or triple bonds or what? Rings present in an unsaturated organic compound. The number of double bonds or triple bonds or rings present in an unsaturated organic compound. Class. Anytime an organic compound contains double bond or triple bond or rings, that organic compound is naturally unsaturated, automatically unsaturated. Who remembers that for an organic compound to go from straight chain to ring, it lost 2 hydrogen, right? Yes. So it's already unsaturated. It had to lose before it could become cyclic. Remember I was showing you. When that 3 straight carbon became ring, all of a sudden they lost 2 hydrogen. So it's also, it means when you lose, means you're unsaturated, you have lost something. So this IHD, the reason why I taught that before this. So this IHD helps us to calculate how unsaturated an organic compound is, class. An organic compound that has an IHD of 1 and that has an IHD of 5. Who is more unsaturated? Of course, 5. The higher your IHD, the higher your degree of unsaturation. The higher your IHD, the higher your degree of unsaturation. So, class, why do we now call it index of hydrogen deficiency, class? Because how much hydrogen you have lost will tell us how much deficient you are. That's again, I'll go back to my same point. When the open chain structure, that 3 carbons was going to cycle, who did it lose? Hydrogen, right? It was hydrogen it lost, right? So when someone is going from saturated to unsaturated, it's hydrogen they usually lose. Hydrogen is the element or atom that is usually lost anytime an organic compound is moving from saturated to unsaturated. So if this hydrogen is the common denominator in all these cases, it therefore means that hydrogen is very important in determining the mode of unsaturation. That's why this topic is called index of hydrogen deficiency. Means how much are you lacking? How much hydrogen deficiency means how much hydrogen are you? Hydrogen deficiency. Hydrogen what? How much hydrogen are you lacking? The number of hydrogen you are lacking compared to your saturated counterpart will tell me how unsaturated you are as an organic compound. The amount of hydrogen you are lacking compared to your saturated counterpart will tell me how unsaturated you as an organic compound. Now, so class, We have rules that we use to determine IHD of an organic compound. We have what? The rules that we use to determine IHD. Class. There are 3 groups of elements in the periodic table that we usually look out for, apart from hydrogen, that will also help us to determine IHD. Why do we choose these 3 groups of families? Because of their level of electronegativities. Class, we choose the group 5 elements, group 6 elements, and group 7. So why we not using group 1? Group 1 and group 2 are not even dragging hydrogen with you because they are electropositive. They are electro what? Group 1 elements are the most electropositive element in chemistry. Is in group 1, potassium. The most electropositive element known in chemistry out of the one that is potassium. Group 1. Group 2, also electropositive, the metals, calciums, the magnesiums. Group 3 and aluminium, they are all electropositive. Group 4 is now in between those ones, but group 5, 6, and 7 are electronegative. Electronegative elements are the ones that usually drag electrons, usually compete. So they should also play a role, apart from hydrogen, they should also play a role in determining the degree of unsaturated. Class, there's an effect a group 5 element has on unsaturated compound. Class, group 5 element usually adds 1 hydrogen to organic compounds. As what? Note, group 5 element usually do what? Cause the addition of 1 hydrogen. Class, group 6 elements usually don't have any effect, no effect, no. And group 7 elements removes 1 hydro. Group 5 element causes an addition of 1 hydrogen. Group 6 element has no effect. And group 7 element removes 1 hydro. So for every group 5 element in an organic compound, you are to do what? Add 1. For every group 6 element, no. And for every group 7 element, remove 1 hydrogen. Please take. For example, if they ask to find the IHD, I have a simple example in your test. For this organic one, C4H BrNO2. C4H for BrNO plus. Before you start looking at for group 4, 5, 6, and 7 elements, there's one thing you do first. Follow me, please. Before you start looking at for group 5 elements, or group 6 elements, or group 7 elements, there's one thing you do. What you do, you ask yourself, how many carbon does this my organic compound have? How many carbon does it have? Class, you want to check the degree of unsaturation, you must compare the organic compound to a saturated organic compound with the same 4 carbons. When I did alkane, and alkynes, who did I say is saturated? Which family did I say they are saturated? Alkane are saturated, right? So we're going to look for who has 4 carbons in the alkane family. It's not butane. Yes. Now, how many hydrogens does butane have? 10. Go to the molecular formula. Go to the what? What's the general formula for alkane? Is it not CnH2n plus 2? Yes. You see why I was teaching all that? So no one will be asking me how do you do this. I've done that already. C4, because the number of carbon is 4, right? Yes. H2 times 2, 4. 2 times 4, 8. Sorry, N is number of carbon is 8. 4. Number of carbon is what? 4. So 2 times 4? 8. 8 plus 2. 10. So class. So class, if this compound was saturated, it will have 10 hydrogen. You have what? 10. Because it's saturated compound that also has 4 carbons. It's having 10 hydrogen. But how many hydrogen does it have? 4. So we need to, that's why they ask us to calculate the index of hydrogen deficiency. For example, this C4H10 is IHD is 0. Is why it is what? Anytime a compound is saturated, its IHD is what? 0. So this guy has 10 hydrogen. Why this guy has 4? Showing you this level of unsaturated. Before you continue now. Class, I didn't mean all these people were not there. If all this BR and NO2 was not, if all these people were not there, what would have just done to get the IHD would have been simple. Follow me. It would have been what? Just say 10 minus 4 divided by 2. 10 minus 4 divided by what? 10 minus 4. 6 divided by 2. If all these families were not there, we have gotten our IHD. Just look for a saturated counterpart that also has 4 carbons. Subtract number of hydrogen here for number of hydrogen here, because this 4 I said the carbons are okay. It's the hydrogen that is the problem, right? So this guy has lost 6 hydrogen, that's why it's unsaturated. 10 minus 4 6 divided by 2, 3. You would have been done. But class, you are not done because there are other elements in play. And check all the elements in play, they are either in group 5, group 6, or group 7, usually. Who is the group 5 element here? Nitro. Check the periodic table, nitrogen belongs to group. Who is the group 6 element here? Oxygen. Who is the group 7 element here? Bromine. Bromine is an halogen, right? So before you start doing your addition and subtraction, you first of all ask yourself, what will be the effect of this group 5 elements to my number of hydrogen? This nitrogen is a group 5. What does group 5 element do to the organic compound? It adds 1. So from 4 hydrogens, our number of hydrogen will increase to 5 due to the presence of nitro. Because every group 5 elements adds 1 hydrogen to the number of hydrogen in the organic. For class, I want to ask you, what if this nitrogen was 3 here, N3? Are we still going to add just 1 hydrogen, or will not add 3 hydrogens? You are going to add 3. Because class, for every group 5 element, add 1 hydro. So don't say I've already added 1, this one represented of them, no. For every group 5 element, we are going to add 1 hydrogen. So we are going to add 3 hydrogen. If it was N3, are we together? Oh, let's not change the questions. N, just N, right? We'll give more questions, obviously. Now, so adding has moved from 4 to. So we have marked group 5 element as done this job. In the exam now, that means you must also go and revise your periodic table, because if I give you elements that you are not conversant with the group they belong. For example, I give you SA now. So then what group does SC belong? Group 6, right? Because I've taught it for people, I've taught it for. What of AS? Yeah? See, for them I started now. You don't know whether to add or remove. You now guess, God, may I add or may I remove? God, I beg you. It's also group. It's also group. It's also group. So I say no. Now, class, so you need to go and get used to it. Class, nitrogen adds 1 hydrogen. Oxygen does not affect at all, right? So maybe you have 10 hydrogen here, it doesn't affect. Doesn't what? What of group 7? Removes 1. So this 5 will now go back to total number of hydrogen is now what? After you have carried out this exercise, is when you will now say, what is the saturated form of this C4H10, right? You will now say 10 minus 4 divided by. Class, in this case, because it's an example, you always do an example, it's always too straightforward, right? Examples are always too straight. Never use too much straightforward examples to prepare for exam. You'll be shocked. All questions will be shocking you because it's like a shock to your system because you are not used to the unexpected. Prepare with questions that come with unexpected twists. Don't prepare with 2 plus 2 for everything is just straightforward. That's why you struggle and you are slow in the exam because you have not been tested. 10 minus 4, 6 divided by 2. You can imagine, this one just added 1. This one move one, say, don't wait for 10 minus 4. Someone that even gets this will not get it, right? Even someone that does not do all this thing, just say 10 minus 4, we get it, right? It's too straight. Why would lecturer give that? Except it's his birthday. Are we together? Let's now take another example. Let's take another what? But at least you get the whole concept of IHD now, right? Calculate the IHD for the compound C6H13 NCl2O. Calculate the IHD for the compound C6H13 NCl2O. C6H13N, right? Cl2. Calculate the IHD. C6H13NCl2O. solve quickly. Before you start adding hydrogen and moving hydrogen, go and find who should be a saturated form of this, right? What is the saturated form of C6? Someone that has 6 carbon in alkane. C6H. And what's the name? Hexane. Right? So you use general formula CNA12 plus 2, right? So class, if this guy is saturated, he should have 14 hydrogen, but he's having 13. You now also factor in the group members that are here and how they will add or remove hydrogen from him, right? So this is a group 5 element, he has 1 hydrogen to this, right? So 13 becomes 14 hydrogens. This is a group 6 element. Oxygen is a group 6 element, does not have any effect, does not have any. But chlorine is a group 7 element. Group 7 element usually removes 1 hydro. But class, we have 2 group 7 elements here. So therefore 2 hydrogens will be what? So after the whole operation, how many hydrogens are left? 12. Total number of hydrogen left is 12 after the whole exercise is done. But if it was saturated, it should have 14. You now find the difference between the saturated form 14 and the unsaturated what? And divide by to get your IH, the 14 minus 12. 2. 2 divided by 2. So the IHD for this compound is 1. IHD for compound is what? Class, are we following? This is how you calculate IHD. This is how you calculate what? Let's move to the next topic in our outline, which is functional group. Please write down functional groups. Functional groups. Functional groups. Please, you are free to go and practice more examples. As I said, do not just relent. Exam can shock you with different types of questions. Practice more examples. The teacher might not be able to take enough examples because he's trying to cover as many topics as possible. So please, it's your job as a student to go and build on what you have been taught. Functional groups. Functional group refers, functional group quickly. Functional groups refers to specific group of atoms or bonds. Functional groups refers to specific group of atoms or bonds. Functional groups refers to specific group of atoms or bonds within a compound. Functional group refers to specific group of atoms or bonds within a compound responsible for the characteristic chemical properties of the compound. Functional group refers to the specific group of atoms or bonds. Functional group refers to a specific group of atoms or bonds within a compound responsible for the characteristic chemical properties of the compound. Responsible for the characteristic chemical properties of the what? Compound. Functional group refers to a specific group of atoms or bonds within a compound responsible for the characteristic chemical properties of the what? Compound. Note that organic compounds in the same functional group will behave in a similar way. Organic compounds in the same functional group will behave in a similar way. Organic compounds in the same functional group will behave in a similar way. Organic compounds in the same functional group will behave in a similar way. Organic compounds in the same functional group will behave in a similar way. Class, in this aspect of organic chemistry, I'll be introducing you to all the main functional groups for your level. Class, by doing this, I'm just introducing you to all the key families of organic compounds. Class, if you look at the definition of the functional group we just stated, we are told that it refers to a specific group of atoms or bonds, meaning that functional group does not necessarily have to be an atom, it can be a bond. Because class, you will give it a structure and have to determine the functional group in the structure. Class, the functional group in the structure is this double bond, class. It doesn't have to be something special, but class, in every way we're trying to say that in every organic compound, there's a special group in that compound that determines how that compound will behave, how that compound will react, who that compound will react with and who will not react with. So the functional group is very powerful because it's one that determines how the compound will behave, how it will react, how it will not react, and every other thing, even the properties. So now the functional group here is this double bond class. The functional group is the double bond in this structure. Someone that has a triple bond, his functional group is a triple. Even someone that has a single bond without any other thing, his functional group is a single bond. The sigma bond. Remember that a single bond is a sigma. Said it several times. Any other bond I heard of is pi. Now follow me carefully. So apart from alkane, alkene, and alkyne, there are other families and their functional groups. Because without functional group, how will we be able to know other families? Class, in this aspect, I'm introducing to other families of organic compounds. But you know the good news, for this aspect of the course, you're only required to know how to name them, draw their structure, and that's all. You are not required to know how they react. You are not required to know. That's why most of you say a lecturer is done with the course, because they still continues in 200. So in this aspect, I'll just be showing you how to name each of these families. Let me list all the functional groups out. We have what we call the alkanes. Halogeno what? And for each of them, I will tell you the key person that is in the functional group in them. Halogeno alkanes are also called alkynyls, alkyne halides. Plus, the key functional group in this member is halogens. The halogens, the what? Halogens. Class, if you go to your textbook and you see anything like X, we use X to represent any halogen in organic chemistry. From halogen alkanes, we then move to alcohols. Alcohols are also called hydroxyalkanes. Hydroxy what? Alkanes. The major functional group here is the hydroxy group OH. O what? So when I say the major functional group, there's the person that is controlling the whole compound. If this guy says don't react, do not react. After alcohols, we then move to aldehydes and ketones. This course will have been long if we have to teach you the reaction of each of these people. No. We are just to teach you their naming and how to draw their structure. At least be able to recognize them and their structure. The people that you need to know their reactions and everything about them is 4 families. And that's where the course will end with. That's where I will end the course with. The 4 families you need to know everything about them, including their reaction and everything. Who are they? Alkane, alkane, alkyne, and benzene. This information will also help when you are doing your personal study. You don't go over it. You just need to know the reaction of these 4 people. Alkane, alkane, alkyne, and what? And benzene. Alkane, alkane, alkyne, and benzene. That's the scope of the course. As some colleagues they say they are done already, they are done. Yeah, it's a short course. Even the book is small. It's a very short course, but wicked. Short and wicked. Halfway together. So alkane, alkane, alkyne, and benzene, you are done with that aspect. Just their reaction. But these guys, at least even if you don't know how they react, in 200 level, you now start this way, you now come to these guys. In fact, the course title of 200 level is Organic Chemistry of Functional Group and Conjugated Pi Electron System. Organic Chemistry of Functional and Conjugated Pi Electron. So here too, you have focusing on these functional groups, how they react, everything about. So leave their reaction for now, but at least you must know that they exist. You must know how to recognize them. They can bring their structure and tell you to name them, but they will not go fast asking you to how they react. They can bring you any of their structure and say name or who is this. You say, this is an alkyne now. This one is an amide. This is an ester. This is an eder. Oh, this is an alkanoic acid. This is a nitrile. This is a phenol. At least you have to see it and say, I know where you belong. for year 1. I know where I can name you, I can draw your structure for year 1. From year 2 now, you must now know how do you react. So aldehydes and ketones, aldehydes and what? After aldehydes and ketones, who is the major functional group? Yes, the carbonic functional group, C double bond O. The carbonic functional group is the major functional group between these two classes. Notice I'm mentioning these two guys together because they have the same functional group but different positions. They have the same functional group but different positions. Follow this. After aldehydes and ketones, we have alkanoic acids. Alkanoic. After alkanoic acids, we then move to esters. Esters are also called alkanoids. Alkanoic acids, the major functional group is carboxyl. So this alkanoic acid combines these two guys' functional group. It contains this carbonyl and also call this OH. So COO. It contains these two guys' functional group together. COO. So you have COO. So alkanoic acid is funny because it contains both aldehydes functional group and the alcohols functional. Esters. Class esters is combination of alcohol and alkanoic acids. When an alcohol RCOOR is esters. I'll explain when I get there. RCOO esters. I'll explain when I get there. Now, we also have ethers. Do not confuse esters with ethers. Is there any ester in this class? No ester. Guy, there is no ester. How can a body be ester? Ethers are oxygen functional group, the oxo groups. The oxo what? We have ethers. Then we have the amines. And we have the amines. Please do not confuse them. Amines and amines. Then we have the thiols. And lastly, we have the nitriles. The amines are derivatives of the ammonia. Amines are derivatives of what? Ammonia. Amines contain both what? The carbonyl group and amino group too. I'll explain each of. This is just the introduction. I'll explain them. Don't worry yourself. The thiols, class, if alcohol has OH, the thiols have S. H, thiols. Then the nitriles contain the cyano group, CN. C2, this is the key functional group, yes. Carbon with triple bond with nitrogen. Carbon triple bonded with what? Is the key functional group in nitriles. That's the key functional group in what? Nitriles. Carbon triple bonded with what? Nitrogen. Carbon triple bonded with nitrogen. Now class, I haven't introduced them, let us now forge ahead. Let's forge. Class. In order to fully understand all these functional groups, there's a silent hero amongst all functional groups. There's a silent family amongst all functional groups that is not usually given its flowers. Very important because it plays a role across all nomenclature and structure, but rarely pronounced as the other families. They are the alkyl groups. They are the what? But the alkyl groups play a thankless role across all our structures. The alkyl groups are quiet because they are not complete, so they are always occurring as branches. And the general formula is CnH2n plus 1. Plus, they usually have one hydrogen less than their alkane counterparts. Remember the alkane family. Alkane has CnH2n plus 2. But they cannot give you 5 naming without this guy inside one of those names. Without here 2-methyl, 2,2-dimethyl, 3-methyl, 3-propyl, 3-ethyl. You cannot have 5 straight naming and you don't see an alkyl. They are always somewhere there. Class, what made them not be too prominent is that they lack one hydrogen less than the alkane family, so they cannot stand on their own. For class, CNH2n plus 1 means that lookups, whereby this guy is CH4. Because number of carbon is 1, right? C1, 2 times 1, 2 plus 2, 4, right? This guy will be C times 1, C, H 2 times 1, 2, 2 plus 1, CH3. CH what? Now this CH3 is not proper because carbon must have 4 bonds. Must have what? But you have to be 3 hydrogens, CH3. So there's always a vacancy here. For class, as weak as this alkyl is, its weakness is also its strength. It is found across all families here. Plus, as a matter of fact, they are represented with the capital letter R. So anywhere you see R here, it is alkyl. Alkyl. And one of my parents do it very well. I'll say ROH. I'll say RCOOH. They're everywhere. RC, RCH, RSH. If you have RX, S halogens, right? ROR. They're everywhere. This is why we say weakness is strength. Because it lacks one hydrogen, it can class functional groups like SIM a lot. Do you know why? Since functional group is the boss, it's looking for servants, right? So there's a free space here for a functional group man. Anybody that practices here will change the name of an alkyl. Alkyl cannot stand on their own. Are you following me? So this is CH3. If you put OH here, what does this become? Alcohol. Alcohol. If you change this to COOH, what does it become? Alkanoic. Because there's a free space here for anybody to take. C, and you have 3N is a nitrile. Is a what? So anybody can come into this last place. So you see why all functional groups like it. Everywhere. So take note of the alkyl group. We'll be using it in explaining each of the functional groups. I won't introduce this guy. It's now time to go to. Right now, let's start with halogenoalkanes. Halogeno what? And they're also called alkyl halides. Halogenoalkanes, also called alkyl halides. So if you wonder what I'm trying to do here, I'm trying to deal with all these guys and let you know them and how to draw their structure. Then we'll now balance with alkane, alkyl benzene and their reactions. Put them together and then alkane, alkyl benzene. Then we'll talk bicyclo compounds. Bicyclo, then touch separation techniques and spectroscopic techniques. Spectroscopic techniques, very important. Separation techniques. Spectroscopic techniques, that is ultraviolet, infrared spectroscopy, ultraviolet spectroscopy, mass spectroscopy, NMR. NMR is what? Nuclear magnetic resonance spectroscopy. We'll touch on those and how they are used. Then go and work on your past questions seriously. Take tough questions, don't just do examples. Think like a lecturer. What can they twist this thing? I've covered my syllabus now, but how can they twist it? So we go to past question. Past question will tell you how he has been twisting it in previous years. How are they setting up other students in previous years? It gives you an idea, okay, this is how they can ask it. You cannot think like a lecturer if you have not done like 3-4 years past question. If you have done 3-4 years past question, you have seen the pattern, oh, so this is how they change it. So this is the topic, but this is how they ask the question. You now think with your mind and then prepare yourself for the exam. Now class, so let's look at halogenoalkanes, also called alkyl. Halogeno, is there a carpenter in the house? Please pause the video first. What is pausing the video? Class, we'll not waste more time. We're not teaching you reaction. Just how to name it, structure, move. Name, structure, move. Name, structure. Quickly, if we finish all this today, we'll go. No stress. We're not teaching their reaction. So don't mind that it's long. No reaction, right? Just how to name structure. So that, because we have 5 days. I'm not coming weekends. Saturday is my driving school. So I have just Friday, Monday to Friday each week. We're not Saturday class. So Monday to Friday. So we are covering this course in 5 days. So if we finish this, in the remaining 3 days, we can cover the remaining ones for sure. Yes. Now, follow this. Follow me. Halogenoalkanes, I have to just tell you what I've already told you about them. You already have no other information. So you know that halogen alkanes are alkanes that contain halogen, right? So if you have 1, 2, 3. All the space are filled with hydrogen, and there's a chlorine group here. You're automatically an halogen, because chlorine is an halogen, and this was an alkane. Chlorine did not come here, it would have been an alkane, right? That's why we call it halogeno-alkane. Also called alkyl halides. Alkyl. Class, if you are naming this as an halogeno-alkane, it means you have to mention the halogen first before the alkane. So we are going to say carbon 1, carbon 2, carbon 3, right? Class, because this chlorine is the major functional group. Class, another importance of functional group is that wherever the functional group is should be where you start counting from. That's how much power a functional group controls. When naming organic compounds, the position of the functional group is where you start counting from. So for example, this could have been my carbon 1, right? But because this is where the functional group is, I intentionally chose this as carbon. So the name of the structure therefore is 1-chloropropane. 1-chloro what? 1-chloro because it's a chlorine group. But propane because there are 3 carbon. 3 carbon means pro, right? This is why you may name it as an halogeno-alkane, mentioning the halogen first before the alkane. But class, halogeno-alkanes are also called what? Alkyl halides. If you are naming it in the alkyl halide format, you must mention the alkyl group first before the halide. Class, if you look at this as if you remove this chlorine, this is an alkyl. Remember that family I told you that they are very important in all families. Because once it lacks, one thing is lacking, is an alkyl. And what alkyl is 3 carbons, right? Propyl. Now, it was chlorine that was here, right? So then propyl chloride. Propyl what? So class, you can either call this 1-chloropropane or propyl. In the propyl chloride format, it means you're mentioning the alkyl group where propyl is an alkyl. Before the halide, chloride. Propyl chloride. So the next person now, quickly without time, alcohols. Remember, when you name them, structure, move forward. Name, structure, move. From year 2, you look at, you come up with your friends in year 2, you see their test, organic chemistry of functional groups. If you're teaching interaction of all these things, your lecture have not been done by now. It's not possible. Some people say their lecture is done within 1 3 for the semester. If they taught all these reactions, you can't finish by now, it's not possible. Because I know when we even started that first tutorial before the lecture resumed. So how come they are done before the second one? So the course, it's like this reaction of this is not even your textbook, so you open your textbook, it's not there. Now, class, alcohols. Class, alcohols are recognized by the presence of what? OH. So let's draw that same structure, but instead of Cl, what will now be there? So class, how many carbons do you have here? 1, 2, 3. So that foundation of how many carbons still stands? 3 carbons, your name must start with pro, right? 3 carbons, your name must start with what? Pro. But this is now propanol. Propanol. Propanols. If it is 4 carbons, buta. 5 carbons, penta. But class, I don't want to name this as an alcohol. I can name this as an hydroxy group. Remember, it's also called hydroxy alkanes. Hydroxy what? Why am I giving you the 2 different names? Because if you only know one type of naming, if they give you a name that you're not familiar and say draw the structure, you did not learn how to name it in that way. You don't know how to draw the structure. But this same guy can be called 1, 2, 3. Notice that I try counting 1. Everybody know the functional group is, right? 1, 2, 3. Class, follow me. This now becomes 1 hydroxy, 1 what? I want to mention the hydroxy group first, naming it as hydroxy first before alkane. So in this format, the naming will end with alkane, an alkane name. The naming will begin with an hydroxy position, 1 hydroxy, and the alkane name will end it. So this 1 hydroxy, with alkane is propane, right? Because 3 carbons pro, so this 1 hydroxy pro. Class, are we following? Are we following? 1 hydroxy pro. So this guy can be propanol and can still be 1 hydroxy propane. This guy can be propanol and can still be 1 hydroxy what? Propane. Now, Class, before we leave alcohol, normally we should have been done with it, but there's something about alcohol. Alcohol can be classified into three. You could be asked in the exam. We have a primary alcohol, we have secondary, and we have what? Tertiary alcohol. So alcohols can be classified into three. Primary, secondary, and tertiary. So in the exam, they could list out 5 alcohols and say, so just check your past question. To circle out the primary alcohols among the following examples. How do you recognize who is a primary alcohol, who is a secondary, and who is a tertiary alcohol? Follow me carefully, follow me. Class. So alcohols can be classified into 3. Primary, secondary, and what? Tertiary. Now follow me, another thing you should note about alcohol before we go to primary, secondary, and tertiary class. If an alcohol has more than one OH group, it automatically becomes a diol. A what? An alcohol that contains 2 hydroxyl groups is a diol. Is a what? That means you have this, look up, OH here, and you have OH here. It's a diol. Diol. So this is 1, 2, 3. This is now 1, 2, 1 what? Dihydroxyl. What's the parent name? Propane. 1, 2, dihydroxyl propane. 1, 2, dihydroxyl propane. 1, 2, dihydroxyl what? Propane. So this is a diol. But if you want to name it as an alcohol, you don't want to bring out the hydroxyl. This would have been, follow this. Propan 1, 2, di. Propan 1, 2. Propan 1, 2. They come outside with the 2 systems. So because if you only know one system, meaning that they give you another system and they say draw a structure, you don't know the system, you cannot draw the structure, even if you know the family, but they gave you in another format. Meanwhile, it's the same family. So those that I know alcohols know everything about it. You know everything about it. Going back to our primary, secondary, and tertiary, how do you recognize the primary alcohol? What do you look out for? And that will enable you to say that this is a primary class. We go to the carbon bearing the OH group. The carbon bearing the what? I'll give you 3 examples. Follow me. Class. First thing first, you first go and what? Observe the carbon that is carrying the OH group. Is the most important person. Because it's the one carrying the functional group. Class. Example 1, example 2, example. Follow me carefully. In example 1, look at this carbon bearing the OH group. How many hydrogens can you count on that carbon directly attached with their 2? 1. Class, anytime you find 2 or more hydrogens attached directly to the carbon that is carrying the OH group, that alcohol is a primary alcohol. I'll come again. Anytime you find 2 or more hydrogens attached directly to the carbon that is carrying the OH group, that alcohol is a primary alcohol. Most, it is on the carbon that is carrying the OH group, the carbon that is carrying the OH. Now, look at this secondary alcohol. On the carbon bearing OH group, there's only one hydrogen attached to it directly. Class, there are many hydrogens around, but what on the carbon directly carrying the OH group is what we are looking at. So it's not just any of the carbon carrying the OH In this one, there's only one. Only what? It's not one or less, one or more, exactly one. Anything more than one or less than one, it's not secondary. Only what? One hydrogen attached to the carbon bearing the OH. Now in the tertiary alcohol class, there is no carbon attached. Sorry, no hydrogen. Why am I saying carbon? No hydrogen what? To the carbon bearing the OH group directly. No hydrogen attached to the carbon. To the what? That is bearing the OH. So with this, I think I've already summarized the definition of primary alcohol, secondary alcohols, and tertiary. A primary alcohol is an alcohol in which the carbon bearing the OH group has only one hydrogen directly attached to it. A primary alcohol, are we together? Is an alcohol in which the carbon bearing the OH group has only one hydrogen. Has only one what? Hydrogen. Attached to it what? Directly. A secondary alcohol is an alcohol in which the carbon bearing the OH group. What did I just say here? My brain just replayed it back to me. Say, guy, what did you talk? Plus, a primary alcohol is an alcohol in which the carbon bearing the OH group has two or what? Hydrogen attached to it directly. Attached to the carbon bearing the OH group, right? Secondary alcohol, the carbon bearing the OH group has only one hydrogen attached to it. Tertiary alcohol, the carbon bearing the OH group does not have any hydrogen attached to it. Class, are we together? This is what you look out for. Why do we say two or more for primary? Because class, look at this alcohol that has only one carbon. It has space to entertain more than two hydrogens and still have OH. Met, because it's one carbon. Meta. It has space to entertain more than two carbons. That's why primary is two or. So there are more than two hydrogens attached to the carbon bearing the OH group. It's still primary, so it goes. But class, for secondary, only exactly one hydrogen is attached to the carbon. And for tertiary, you will never find any hydrogen attached to it direct. Is that clear, class? So going ahead to name these alcohols. So put halogen out. Just put that alcohols now. Now, also known as hydroxy. Now, what is one of these alcohol? Proper what? Propanol, right? Or 1-hydroxyl propane, or 1-hydroxyl propanol, or 1-hydroxyl. If this week is for organic chemistry, if you are smart, next week now we'll jump on that chemistry. You will not have time to catch up. If you are not reading every night after this marathon, you are not helping yourself. If I were you, say this week is marathon, as the odds. So that as you are reading, questions can even pop up like, come ask me tomorrow. Tell yourself this week, anything organic chemistry must finish. You can have other courses to read. We divided this month into 4 weeks for your 4 major courses. Chem 131, Chem 132, Phys 112, Phys 115. After that, exam September. 4 weeks makes a month. But you have other courses apart from the 4 courses, right? So imagine if you know, even if we gave you 1 week to only Chem 131, you cannot still finish it. Then you're on your own then. But when we have time to read other courses, GS is there. Why not tell yourself, okay, this week, let me know that I'm not doing anything Chem 132 again. As they're teaching every night, I must revise. Because every day I'll be covering more topics till I'll finish it, right? Why not just finish with us? So Friday I'm done. Then weekend I can also read other courses. Why not follow with us like that? Even if you have not been reading before, it's okay. Let me just use this marathon to push myself. Every night, as I did, any topic they don't teach, I'll go revise some. Go and look for every person on that topic. Play it very well for exam. Be ready for. That's a smart thing to do. But you should do what is in your mind this night. I know you. Yes. Don't worry. That TikTok. There's no night you don't go on TikTok. Except you don't have data. Break that record this night. Say to do no TikTok tonight. No TikTok night. No TikTok. No WhatsApp status checking. That one is going to be aside. That one go hard though. The girl one girl where they look at status. She show herself too much. Leave that girl alone. Leave that girl. Say this girl, she show herself for the hostel. She don't go post again now. It's not your It's not your business. Take this thing very serious. This night, everything about Chem 132. Tomorrow, I'm going to bicyclo compound skeletal structures condensed formula tomorrow. As they're teaching that thing, I will go and master it. Anything I see person in that thing, I must answer it. Next tomorrow, I will now go to the reaction. Alkane, alkynes, benzenes, all their reactions. Electrophilic substitution reaction, nucleophilic substitution, all the reaction, types of reaction, homolytic cleavage, heterolytic cleavage. I'll break all the reactions down. Then Friday, winter, spectroscopic techniques and all the separation techniques of organic compounds. Small other topics that I just touch that maybe are not really big topics. We just touch them together to round up them. If time, don't revise past question. That's the plan. That's the what. So let's work together. Let's work. Take this week very serious. As you go, or you can tell yourself, if I read for 3 hours straight, I will reward myself with TikTok. If I read, sometimes you can do that to reward yourself. I will not press my phone. Me, I don't read press. If I read very well, then I'm not going to press my phone. It's easier to play when you have worked hard. I've noticed that it's more rewarding. You won't feel guilty when you have done work well and you are playing, right? So I don't read. Imagine reading 6 hours and you now press your phone. Will you be feeling bad? To read good 6 hours and everything enter your brain well and you're not pressing your phone, you know. But imagine you have not read for the whole month. And you spend 8 hours on TikTok or 6 hours or 5 or 2 hours. You will invest. Even you, I said you will. Let me tell you, until you graduate from this school, you will never fully press your phone with peace of mind. Or you will never have that peace of mind. Let me tell you, there's one peace of mind that comes when you finish school. When you have finished school completely, you have graduated, there's one peace of mind that will enter you that you don't even know. As a student, as long as you're a Nigerian student, you are automatically stressed. You might not even know it, you're already experiencing, but you don't know it. There's no time you can really play willfully. Have you noticed it? Like you're just, you always think there's always one exam. After this semester, there's year 2 exam. After year 2, second semester exam. After there's year 3 exam. Until you finish school, you will never have that piece of. The day we drop our last pen. Why are you think students are always very happy? They will resign it. It's not, they know that it's, one more, no, it's every time. Exam be 2-3 months exam. Till you graduate 2-3 months exam pressure. Do you understand? So take it very serious. Now let's go. Please play the video back. I hope it was not recording all these things, so I will just. Were you recording it? Oh, yeah, no, it's part of advice. It's not bad. And let's say anything bad. Now follow this. We name this propanol. What do we name this now? Propan2. And what do we name this? Why do we call it propan2? Carbon 1, 2, 3. OH on second. What do we name this? 1, 2, 3. So this is a branch. 2-methyl. 2-methyl propan2. Why do we say 2-methyl? Because this is a branch. It's not part of the chain. It's a, and it's attached to the second 2-methyl. But there's an OH to the second carbon. 2-methyl propan2. Now let's go to aldehydes and ketones. Aldehydes and what? Aldehydes and ketones last. Follow this. Class, aldehydes and ketones have a key functional group that is called the carbonyl group. Called the what? Carbonyl groups. But I'll differentiate them now, class. Aldehyde will be on this side, ketone will be on this side. Class, they have the same functional group called the carbonyl group, but the difference is that in the aldehyde family, the carbonyl group is found at the end of the chain. Or let's say, let me not say end, let me say at the beginning of the chain. They are found at the terminal ends because every organic compound has 2 ends, right? 2 ending carbon, right? No matter how much you draw carbon, at the end of the day, you have 1 carbon at this end, 1 carbon at this. So they are either found in those ends. So you can understand it that way. Look at this. Because this is an aldehyde, it has a carbonyl group. These ketones on this other side also have a carbonyl group, but I'll show you how they are carbonyl group. So class, follow me. Why the IBS carbonic group is found at the ending carbons, it can either be here or it can be here. The ketose carbonic group is found in the middle carbon, in the middle. Now, another difference, because this guy is found at the end, this carbon can still accommodate one more hydrogen. So the carbonic group of an aldehyde has hydrogen attached to it, but the carbonic group of the ketone does not have hydrogen attached to. Remember, the carbon can only have 4 bonds, right? So if this is 1, 2, 3, there's a reason why there's no bond here. Because you put 1 bond here, it's now making it 5. Carbon can only have 4. So it only has 1, 2, 3, 4. So there cannot be a bond here. So how we recognize the ketone easily? The carbonic group does not have hydro, and it's always found in between 2 carbons. It's always found in between 2. The carbonic group is found between 2 carbons in the middle of the chain. Why RBI is the carbonic group is found at the end of the or beginning of the chain, the terminal ends, the ending carbons of the chain. So because of that, their naming will be different. Even if they have the same functional group, their naming will be what? So class RBI's naming end with NOATE. O. If this 3 carbons and this proper NOATE. Proper what? Sorry, proper now. Aldehydes are so called alkanals. Alka what? And ketones are called alkanones. Sorry, my bad. Ketones are called alkanones. So aldehydes are called alkanals. So the name will be proper now. Proper now. My mind is ready in esters. Proper now, because the esters are called NOATEs. Proper what? Now. And proper no. So class, aldehydes naming end with nows, ketones naming end with what? No. Aldehydes naming end with now, ketones naming end with no. So class, proper now, proper no. Because aldehydes are called alkanals, ketones are called alkanones. Let's play with thiols and nitrites quickly. These thiols and nitrites, remember when we had, please look up, class. This is propanol, right? OH, proper. But if this O is now replaced with S, it's no longer an alcohol, it's a thiol, it's a what? So the namings of thiols end with the same thiol. So this is 1, 2, 3. So this is propane thiol. Propane what? Propane thiol. So just count the number of carbons, and once the SH is there, put the thiol. If it is 4 carbons, butane, thiol. 5 carbons, pentane. Very straightforward. It doesn't have primary, secondary, and tertiary. Are we together? So that's thiol for you. That's thiol for. Now let's go to nitriles. Note that it's just fast because we are not doing the reactions. If because the reactions might still be in the second family or the first family, but after that, how they react, different kind of reactions they undergo. Like this aldehydes and ketones, they undergo a reaction called the Canavaro reaction. You know called Canavaro. Canavaro. Yes, 200 level, you know called Canavaro reaction. There is a kind of reduction reaction that are kind. Now, nitriles on the other hand, nitriles. What will you see that you say this is a nitrile? You see carbon with 3 bonds specifically, and then nitrogen. This is a nitrile. Class. This nitrite could be filled with hydrogen here, or could be filled with another alkyl group. Class, this is 1 carbon, so we're going to say metanitrile. Because it is only 1 carbon, metanitrile. But this one that is 2 carbon, that is ethanitrile. 2 carbon ethanitrile. But this is not the way of naming nitrile actually. Class, nitrites could also be named as the brand that's attached to it, and this as a cyanide. For example, this hydrogen, right? I could have called this hydrogen cyanide. Hydrogen what? Because C triple bond N is a cyanide. It's what? So I actually call this hydrogen cyanide. Another way of naming it. Remember I told you the importance of having different point of views. So that if they ask you to draw something, you won't completely be lost. Class, this one now can become methyl cyanide. Methyl what? For this is methyl, right? And this is cyanide. But the same person is still ethanitrile. The same person is still ethanitrile. So please take note. What's it called? Acids. For the alkanoic acids class, you will see clearly COOH. See what? Now when drawing the structure, this is how the COH appears. When you see COH, when the structure C double bond O, then C to another OH, single bond. So the C to the oxygen is double bond, but the C to the OH is single. This is the actual structure. Meaning that if you look at this carbon now, carbon can only have 4 bonds, right? 1, 2, 3. So there's only one more space for an alkyl group. Whatever alkyl group to come in. Whatever alkyl group to come. If it is the CH3, you have CH3, then COO. What will you now name this now? Ethanoic. Now, it's very common for students to forget to count the carbon in the COH and just be saying this C here and say met. No, count the carbon in the COH. In fact, this is the carbon 1. So the carbon in the COH, even if it's a part of the functional group, is also a major part of the chain. Ethanoic acid. So they are naming it noic. Ethanoic acid. Which is 3 carbons, propanoic, 4 carbons, butanoic, as the case may be. Now that's alkanoic acids for you. Next person we are looking at now is esters. Is what? Plus, the funny thing about esters, the esters are only existing because of the reaction between alkanoic acid and alcohol. So this is the only time we'll mention reaction, because you cannot talk about esters without indirectly talking about the reaction of alkanoic acid and alcohol. Because for esters to be formed, an alkanoic acid must react with an alcohol in a reaction called esterification. Esterification. So class, for esters to be formed, an alkanoic acid CH3COOH must react with an alcohol. Let's say C3H7OH. Follow me, please. For esters are also called alkanoids. Class, during the reaction between alkanoic, this is an alkanoic acid, this is an alkanoic, and this is an alcohol. During the reaction between alkanoic acid and alcohol, the alkanoic acid will lose hydrogen and the alcohol will lose OH. Class, this is almost a replication of neutralization reaction that occurs in inorganic chemistry, when acid and base react to form salt and water. So we usually call it esterification organic neutralization. So neutralization that occurs in organic, because what we're going to have also is salt and a water. We're going to have an ester and a water. Because the hydrogen is lost from here and OH is lost from here. Although ester is not exactly a salt, but esters are very good precursors that can produce organic salt. Esters are good precursors of organic salt. Then you have sodium ethanoate. Sodium ethanoate only exists because esters exist during the saponification reaction. What causes saponification reaction of organic chemistry? Now follow me, but let's not go too deep in that. Now follow me now. H is lost here, OH is lost here, and we have H2O. Water is formed. Water is. Now, since this guy has lost hydrogen and this guy has lost OH to form water, the remaining part of this guy now reacts with the remaining part of this guy and ester is formed. So what's the remaining here? H has left here. CH3COO. Now join with what's the remaining here? C3H, and this ester is formed. This ester is what? Let me bring it out in structural form. Draw the structure. But this is simple, just a CO. How does this CO play out? So this is CH3, right? COO. Now follow me. Double bond O here. Another single bond O here. Another single bond to join the CH3 now. To join the C3. C3, right? H7, H. We count the 7 hydrogen there in all those spaces. L is hydrogen space, right? All the spaces are filled with hydro. This is the structure of. Now, how do we name esters? But at least you understood that it was formed now, right? Anytime an alkalic acid will acid an alcohol. Plus, if they will give any reaction of functional, it might be from this side. They might give you an alkalic acid and alcohol and say, name, draw the structure of the ester formed. Just know that who loses the hydrogen? Because be careful who loses the hydrogen, because two of them have hydrogen or H, they still H here, right? If you can move hydrogen from here and move OH from here, you have a very funny structure. How together. So H must go from the alkanoic. If you need to write it down, write it down. Please do not be deceived by those that are not writing. Some people already attended the first marathon. Before your lecture started becoming serious, we had a first serious batch of marathon where I covered all your courses for once. Okay, 131, 132, please 1, please 1, 2. I covered everything. This is the second batch of marathon again. So they already have the notes, so they're just listening and updating whatever they missed. So please do not be moved by someone that is not writing, and you too are not writing when you don't have a notes. Right, so the H goes from the alkanoic acid, the OH goes from the alcohol. So that whatever is left of two of them now joins together. Now, how do we name it? Class. When naming esters, we name ester. Ester is one compound that we name from the front. Class. In front of every ester is a clear alkyl group. Mention the alkyl group first. In front of every ester is a clear what? This is C3H7. This is an alkyl group because it's one hydrogen less. The real thing should be C3H8. Propane is C3H8. But this H7 means that one hydrogen less alkyl. Alkyl usually have one hydrogen less than alkane. Please follow me. Alkyls usually have one hydrogen less than the alkane. So this is propyl. 3 carbons make pro, right? Mention the alkyl group. This is a propyl. After mentioning the alkyl, count how many carbons are left. 1. So 2 means H, right? In organic chemistry, 2 carbons means what? So propyl ethanoate class. Alkyl groups end with noates. Propyl ethanoates. I think this is one that is a bit complex more, right? Especially if they are new to organic chemistry. I'm talking to those that just joined this marathon. I'm not expecting those that learned the first one should be too confused. This should just be consolidation, right? But if you are new to organic chemistry, you might be lost here. A bit. But let me come again. Please follow me. Please follow. When naming esters, there's always a clear alkyl group in front. Propyl. It could be methyl, it could be butyl, whatever. Count the number of carbons and find out. Name it first. Then count how many carbons are left. Total naming the except from the alkyl. Don't now come and count these 3 carbons again. We have already named it as pro, right? Propyl. How many carbons are left? 2 ether. No. Propyl what? Let me see if you understood what I'm talking about. If you have C2H5 COO CH3. What is the name of this ester? C2H5 COO CH3. C2H5 COO CH3. Because this is methyl, right? Methyl. You are looking at these 2 carbons. What's this third one? I'm looking at the movement of your mind. I've not even said it out. I'm returning it back. Are we together? She wants to say methyl. She's trying to back to methyl. You're already falling for the mistake. 2 instead of adding this one. 3. This is methyl propar. So please don't be deceived by these 2 here. You now forget that there's another carbon to make it 3. Pro. So you now say X because you're saying 2. So 3. Ester is done and dusted. Now, ethers are very straightforward. Ethers contain the oxo functional group. Plus, anytime you see oxygen flanked by 2 alkyl groups, you have just met an ether. So welcome her carefully. You have just met her what? Ether. So how may I help you, Mrs. Ether? I know someone's name that is Ether actually. I think yes. I say see Esther. I say no, it's Ether. I say Esther, no, Ether. You know you have to explain your name. Know that you are. Class, follow me. Ethers. When you see an oxygen in the center and you see 2 alkyl groups, you have met an ether. They are very rare, of course. And how do we name an ether? Very simple. Acknowledge the 2 alkyl groups. This is an alkyl group called methyl, right? And this is an alkyl group called what? Ethyl. Then acknowledge the alphabetical order. Ethyl starts with E, methyl starts with. So you're going to start with ethyl, methyl, ether. ethyl, methyl. But class, there are some cases whereby the two alkyl groups are the same. So CH3O, CH3 would not be dimethyl. Dimethyl what? Either. Dimethyl either. Either is done on dimethyl either. No, I'm not playing the main exam. I'm just chopping off my, it just looks like a bucket list. So I'm meeting my targets, or whatever you call it. Dimethyl either. Please, can you pause it? I think I've been fasting. Let me go right. Thank you. Alright, amines class. Amines are derivatives of ammonia. Amines are derivatives of ammonia. Follow me. Amines are derivatives of what? Ammonia. Meaning that when you say something is a derivative, it means that this compound originates from ammonia. Because amines are formed when one or more hydrogen from ammonia has been replaced with an alkyl group. Amines are formed when one or more hydrogens from what? Ammonia has been what? Replaced with an alkyl group. So look at this. Let one of the hydrogen go and be replaced with CH3. An amine is automatically born. A king is born. An amine is born. Class. And this amine is a primary amine. Because anytime an amine has only one hydrogen replaced, it's a primary amine. But if an amine has two hydrogen replaced, it's a secondary amine. So if another CH3 replaces second hydrogen, so two hydrogen has gone, only one hydrogen is remaining, it's a secondary amine. If you now look at an amine, they have finished his life completely. I'm joking. I'm just trying to, when you laugh, there's a kind of hormone that is released, whether it's dopamine factor, you feel good and you get more energized. When all three amines have been replaced, class, when all three hydrogens have been replaced, then you have a tertiary what? So you have primary, secondary, and tertiary amine. Primary, secondary, and what? Tertiary amine. Primary amines are amines in which only one hydrogen have been out of the three hydrogens in ammonia. Out of the three hydrogens in ammonia. Before we started, look at ammonia, NH. When only one hydrogen has been replaced, a primary amine is formed. When two hydrogens have been replaced, secondary amine is. When all three hydrogens have been replaced, a tertiary amine is formed. All these videos I'm doing, I'm very happy. When I become very, very old, I have something to be watching on myself. It's going to be fun. I can't wait. I'll have something to reminisce on. It's good. I'll just show my children now. So see your daddy, I'll teach him in uniports. I'll not just say, go and read your book, you're not serious. I'm not just saying what I was not doing. I was telling my students back then. So I'm not harsh on you, I'm not strict on you. I want you to pass. I also taught students. The evidence. Very important. Very, very. So it's good. All work has advantage and disadvantage. Yeah. Please pause it. Hope we're pressing the right things. I don't want to see anything funny after this class. Don't shock me, I'll not see that. Because I have promise of students, the students I can't make it, I'm not feeling fine. Students I've paid that first time, but many of our students are not that paid. So they just say, class, do video for us. I'm okay, don't worry. So that's why we're doing this. Now follow me. Like, see, like physical class is the best, if you can. The best, honestly. Now class, CH3NH2, right? So we're going to say, naming this now, we're going to call this methylamine. Methyl. Because this is methyl, right? Amine, methyl. This is dimethylamine. Dimethyl. And this is trimethylamine. Exactly, I'm coming there. It's like in my mind. Thank you. Now, if they are not the same, it would now have been different. Like if they were different. Why is it easy to say methyl, dimethyl, trimethyl? Because they're all methyl, right? Shouldn't be too straightforward. What if they are different? Now, look at this. let's start with this is the secondary amine, right? Class, this is ethyl, right? And this is methyl, right? You now have to consider alphabetical order. So this would be ethyl E, then ethyl methyl amine. Ethyl, so E comes before M. Ethyl methyl amine. Let's go to amides around the for today. Amides. Okay, one more thing, I forgot. Listen up. Class. If you don't call this ethyl methylamine, there's another way of naming this. Look up. Let's expand this very well. Look up. This is C2, right? 2 carbons. Carbon 1 carbon. And this H5. Follow me. Class. You can also name this in terms of branches. Class. This is secondary amine. This can only happen with secondary and tertiary. Don't take notes. It can't happen with primary. Class. These are 2 branches. Who has the more carbon? This, right? This should not be the parent name. So 2 carbons means ethyl amine. Ethyl what? Now follow me. Ethyl. Then this guy now becomes a branch. And it's branch on nitrogen N. So I'm going to say this structure is also N-methyl. N what? Ethylamine. N-methyl ethylamine. I hope we're still here. Make sure you're almost done. Do it well. End it. If you're still in this last 9, means you have a good level of resilience. Well done. Show something about you, the resilience. Class N-methyl. Why we say N? Normally, the normal organization will say 1 methyl, 2 methyl, right? But it's not 1 or 2, it's N, because the methyls are not attached to any carbon. So you cannot say carbon 1 methyl or 2 methyl. It's attached to N. If it was attached to this first carbon, say 1 methyl, 2 methyl, right? But N to N methyl ethyl. So the person that has the longest carbon will not be a branch. It will become ethylamine. If it's 3 carbons, propylamine. 4 carbons, butylamine. Then the smaller carbon will not be the branch, and you ascribe it as a branch. Say N-methyl ethylamine. Now, if it's a tertiary amine, let us say that we have another one like this N. We have CA3 here, and you have another CA3 here, and then you have 4 carbons here. 2, 3, 4. This guy has the longest carbon. Why these 2 have 1 carbon? So the parent name is 4, which is butylamine. So if this is butylamine, these 2 are branches. So that will be N dimethyl. Di what? Butylamine. N dimethyl butylamine. And this is a tertiary amine, right? Because all the hydrogens in the amine have been what? Have been replaced. Amide, I will go and rest. Some of you are in training of your house already. Now rest. Class. Amides have a key function. They have 2 functional groups. They contain the carbonyl group and the amino. Amides. Now, do not always confuse amines with amides. These amides are even very important in biochemical systems. They play a key role in peptide. They are also called peptide bonds, actually. The amide bond, the peptide bond, they play a key role. They are the ones that actually bond groups of amino acids together. Remember that the unit of amino acids make up a protein. You know, when proteins are broken down to polypeptides, peptones and polypeptides, from peptones and polypeptides to smaller amino acid units. Anyway, let's not go to biochemistry. But now, what I'm trying to say here is that amide is a very important, amide bond is a very important bond in biochemical systems. Class, follow me. This R C double bond ONH2. This R is an alkyl group, and anybody can go there. It will be CH3, C double bond, NH. Notice that in this particular amide, these two hydrogens are still intact. Anytime you have an amide and the N is still carrying two hydrogens, just know that it's a primary amide. It's a primary what? Let us name this primary amide first. Class, this guy just counts the number of carbon 1 and 2 means H, right? So this guy is ethanamide. Why are you laughing? Why are you laughing? This is the way I'm saying it. What if you had to learn this in your language? Imagine. Hey, which language do I even use now? You don't use your language, say hi, God, don't push. Ethanamide, primary amide. Et, why? Because it's 2 carbons. Et is 2 carbon, ethanamide. If this number of carbon, let's increase propanamide. 4, butana, 10, decana, primary amide. In primary amide, we have not yet touched any of the 2 hydrogens, right? In secondary amide, now one of the hydrogen has been replaced with an alkyl group. Follow this. In secondary amide, one of the hydrogen has been replaced with an alkyl. So we are going to have one, two, three. C double bond O. Now this N, instead of NH2, I just have NH. One of the hydrogen has been replaced with CH3. I replace what? So one of the hydrogen has been replaced with an alkyl group class. This alkyl group is methyl, so we're going to say N-methyl. N what? N-methyl. How many carbons are on the longest chain? 1, 2, 3. N-methyl butanamide. N-methyl. N-methyl butanamide. N-methyl butanamide. N-methyl butanamide. N-methyl butanamide. N, I think that N will not be too surprising to you, but I've done it in our minds, right? You know what N is? This CH3 is attached with N, so N-methyl. Now, why is it butanamide class? 1, 2, 3. The main chain that is attached to the main carbonyl and N is 4. So the longest person is the main parent name. Every other carbon attached to that N is a branch. Now, what if this last hydrogen is also replaced? We are going to have this C3 and this C2H5. This is the longest carbon, so this is butanamide, right? We are now going to have N, this ET, right? Please follow. This is the last thing, don't worry. You are very close to your pots of soup. Very, very close. We are going to have N-ethyl. N what? I mentioned E before. N-ethyl, N-methyl, butana. Class, you know, there's a point you get to where, even in some namings, nobody needs to tell you. You just know what feels right and what is wrong, right? You just understand. It's just a concept. This organic chemistry. Okay, I think you get. Learn to know when you are naming jargons in the exam. Are we together? When you are writing nonsense, learn to know, even if it's a signal, like maybe your body will be scratching. Some of you have natural body tells. Anytime you are doing nonsense or you are writing nonsense, your hair will be scratching. These girls, new hair just made, but scratching you. Say, I'm writing nonsense. Do you understand? Some of you, nothing will scratch you till this all come out. I'll be together. All right, class. We'll come to the end of today's class. If you are following us on YouTube and you enjoyed this class, kindly subscribe to the channel so that we can get more videos like this. And this class doesn't end there. We'll continue tomorrow. It's a series, it's a 5-day series. So expect the next video tomorrow as well. So step by step, we'll be covering everything in organic chemistry. And we hope we have been able to make you understand this course very, very well to your understanding. Thank you for watching. All right, thank you.